So now we will go for assignment 5, and we have this is part 2. In part 1 we have solved 5 problems. Now we will go with next problem, that is problem number 6. Here also we have to determine the displacement. Now we have to go first BMD for 2. Now your conjugate beam and actual beam in this case will remain same. And then we have this as 20 kilonewton. So first I will take, and from this I will get this as 10 kilonewton. We will get this as 10 kilonewton. And distances we have 2 meter, 2 meter. Now bending moment we have to plot M by EI diagram. So now what we will get in this case? So WL by 4 we know. So that is 20 we will get here. So we have M by EI diagram, M diagram. So bending moment diagram we have this as 20. So this is M diagram, M by EI diagram. Now you can see on this portion we have 2i, here we have I. So we have to divide it by these respective values. So if I will divide on this side by 2ei, then we will get this value, that is 10 upon ei, and this will remain as it is, which will be 20 upon ei. So this value will be 20 upon ei. Now arrows you have to decide, I already mentioned. So let us, we will have these arrows downward. Now second we have couple, and now in couple we will have this as clockwise 5. So automatically reaction we will get it as we have seen. This will be 5 by 4, and that comes 1.25. So here also we will have downward 1.25. Now bending moment diagram, if we will see, then we will get bending moment diagram in this fashion. 1.25 into 2. So this is 2.5, this is 2.5. So we will have, this will be M diagram, 2.5, 2.5. Now on this we have 2i, here we have I. And accordingly we have to go for it. And if we will plot this, then we will have these diagrams as, so this we will get it as 1.25 upon EI. If we will go upward, then we will have 2.5 upon EI. And then we have 0. Then again we have, this will be downward. So we have to show arrows upward, and upward, then we have to show downward. Arrows are exactly opposite. And now conjugate beam, if we will see conjugate beam with M by EI, then you will have, this will, conjugate beam will remain as it is. And then we will have diagram, first due to concentrated load. So we will have this diagram. So actually we have do it correct. So just I will rub it. And then we have exactly that diagram that will be below it. So we have here 1 point, first one, and here we have arrows downward. And if we will plot a second diagram, this is M by EI diagram. So this value is 20 upon EI, this value is 10 upon EI. This is conjugate beam with M by EI diagram, and that will gives us shear force, gives slope, and bending moment gives us deflection. So now we will have in this fashion. Now this is 1.25 upon EI, arrow we have upward. And this arrow we will have downward, and this value we have 2.5 upon EI. Now we have to find out the displacement and slope at B. So displacement means moment. So we have to find MB, and we have to find shear force at B. And therefore we have to find reaction. So we will have this as VA1, and we have this as VA2. And if we will take moment about C of both, we can have value of VA directly. So I will take this moment VA into 4. Now if we will calculate this, so we have 1/2 into 2 into 10. and we will get total value same 10 upon EI of this triangle, and for this triangle we will get 1 half into 20 upon EI into 2. Again we have 20 upon EI because we have 1 half and 2, so same we have 1.25 upon EI for this triangle and 2.5 EI upon for this triangle, because base we have 2, so this will be area of this. So we will have VA into 4 minus 10 upon EI, we have this triangle, and into moment about C, so we have this will be 2 by 3 plus 2. So we have this value 2 by 3 plus 2, and that is 2.67. Then due to this 20 we have minus 20 upon EI into 2, sorry, into, because this is area and that we will give it as 4 by 3. So this will be 2 into 2 by 3. Then we have, due to these arrows are upward for 1.25. So plus 1.25 and same as 10 upon EI 2 by 3 plus 2. And then due to 2.5 we have minus 2.5 EI into, this will be same as 20, that is 2 into 2 by 3, and that is equal to 0. And if you will calculate this, then you will get value of VA, and that value we will get it as 13.32 upon EI. Now we have to find the slope at B. So what we will get? Therefore, theta B is equal to shear force at B equal to VA. VA we have 13.32 minus this area 13.32 upon EI minus 10 upon EI plus this area. We are considering area on left of B, and then plus 1.25 upon EI, and this will gives us value 4.57 upon EI, 5857, and we have this will be option, that is B, slope. Now you can have bending moment also. So if we will go for bending moment, then we will get delta is equal to bending moment equal to 13.32 into upon EI into, we have 2, then we have due to 10 EI minus 10 upon EI into bending moment, from this we have 2 by 3, and then from plus 1.25 upon EI into again 2 by 3. Now if we will calculate this value, then we will get this value, that is 13.32 into 2 minus we have 20 plus, sorry, we have 13.32 into 2 minus we have 20 divided by 3 plus we have 2.5 divided by 3, and this get 20.8. So we will have 20.8 upon EI, and if we will calculate 62.5 upon 3, then it is 20.83. So we will have both values correct, that is reflection as well as slope. So option is B. Now we will go with this problem. So we will have to go for horizontal displacement of joint C. So unit load method we have to go for. Then we have to prepare a region. Then we have origin. Now you remember we have in Castigliano's theorem limit m, and now here I am saying as small m because we are with unit load method. Now due to this we will have a region CB, region CB, origin C, limit 0 to 8, bending moment we have -1 because it is clockwise. So I'm now writing only M. Then we have BA, origin we have B, limit we have 0 to 10. Now we have moment. Due to this, minus 1 will be as it is. So minus 1 minus, due to UDL we have 0.4 into x square by 2. So we will have this value, that is 0.4 into x square by 2. And now we have to go for small moment, and for small moment we have to apply unit load. Now we are interested with horizontal displacement. So I will draw this diagram and I will apply one value over here. Now this we have 8 meter and we have this value, that is 10 meter. Now we will apply unit load as moment is given in this direction. So I will apply or we will go in this fashion also, no problem. So now we will have moment here 1 into x anti-clockwise. So plus m we are going to get x. And here if we will see, so we have 1 into 8. So we will have 8 over here. Now, and from this we will get, that is delta equal to integration m into m dx upon ei, and that is 0 to L. And now we will go for this. So we have 0 to 8 minus x into dx upon ei. Now I will separate out this term here only. 0 to 10, 8 into dx upon ei minus 0 to 10 point. So 2 4s are 8 and this comes your 1.6. So we have 1.6 into x square dx upon ei. Now 1.6 we have 0.4 into x square by 2 into 8. So we have 2 4s are 8 and 4 into 0.4, 1.6. Now if you will calculate these values, then first value you will get it as minus 32 upon ei. Second value you will get it as minus 80 upon ei. And third value you will get it as minus 1600 upon 3 ei. And if you will calculate this value, you will get it as minus 1963 upon ei. Minus sign shows your displacement is not towards right, it will be towards left. So 1936 upon 3 ei, and we have option as D. So we will stop here only. Remaining problems we will go in the next video. So thank you.